present course that we are studying, there seems to be some kind of gap between what I have in my mind and what I am seeing on the ground. The gap between the expectation and the performance is widening by the day, and therefore I want to spend today's class making it clear one more time and probably for the final time on what are the real objectives of this course. Before I give a blueprint of the process that I expect all of you to follow, which I have already given, I want to make one thing absolutely clear. Contrary to what you may think, I personally feel that all the students in my course are quite intelligent. I am not assuming that all of you are so dumb that you can't understand what is to be done in this course. I am very much aware that all of you are very intelligent guys. But unfortunately what has happened is that more intelligence always is mixed always with lot of laziness. So I know very well that it's not the lack of intelligence but the dominance of laziness which is making you not to work. How much more time is it? 1 year from now, hardly 1 year from now, all of you will be having 2 to 3 jobs in your hands. And absolutely very sure, most of you are already well prepared to work in some company and the placement season begins. I am quite sure most of you will get placed very easily. Next time, next year by this time, all of you will have a job which will promise you more salary than I have worked in past 3 years. I am very sure about all that thing. I am very sure in next 1 year all of you who want to continue your studies will secure admission for next 2011 fall or 2012 spring. Very natural, I know all of you will do it. So at best you should consider that this particular semester is a concluding semester of your engineering studies. 7th semester I have redesigned the whole curriculum so that the topics that we are studying are basically some kind of new topics which will just give an introduction to some new subjects. 8th semester, of course, there are no subjects to study except for a very long project that you have to carry out. So in all practical sense, this semester is the final semester where you are doing the regular rigorous study. So in this context, you should look at what I expect you to do. I know all of you can do all the ordinary stuff like this. It's very easy for you. Don't I install, work around with 100 CMS in a day? You can. I know that. That is why we are pushing the envelope a bit further. I know only you guys can do it. If I don't push, you will not do it. In a final attempt to make you understand what really is meant by an engineering approach to problem solving, this course has been designed. This course should be the culmination of whatever you have learned till now. I said this is a climax. All that you have studied till now should add up, should help you in this course. Is it happening? Is a question. This is no ordinary course. The objectives of this course are much broader. We are very ambitious in this course. We want all of you to understand the real problems associated with developing a project. Deployment is the word. I keep on repeating this. Not development, deployment. Development you can do, you are well versed. I am not saying you are very perfect, but you should believe my words, because I go to many engineering colleges and talk to the students there. I know where you stand. You are far, far better than most of them. So that is why you are here. That is why we take extra trouble to see that you shine even more. Between the model. If we leave you to work the way you want, you will keep on giving 100 excuses every day. Ultimately doing nothing. As I keep saying, you fellows are very good in sweet talk. You can convince anyone through your talk that yes, you are so innocent that no mistake has been committed. But I am not here today to indulge in a kind of blame game. I am here to make sense. So as a man of reason, let me tell you that you should approach this particular course, at least from now, in a drastically different way. As one of my favorite example goes, engineers are not asked to build a one-bedroom house. Anybody can build. Engineers are asked to build a 70-floor, 80-floor buildings. That is where your engineering thinking should come. Taking the same example in our field, I am not interested in asking you to write a software where you configure a CMS and do something with that anyone can do. You don't need an engineer to do that. Come on. Download the CMS, double click on that, untap. Why do you need engineers to do that? Anyone can do. Then what should you do? That is the question. Are you satisfied with doing that? Or do you seriously want to do something more? The choice is yours. Please believe me, I will be the last person to question your choice. But it's your life. How much you want to learn, you decide. But from my side, I will push you to do something more, because I know you can. If this was some XYZ college, I would not tell the students to do this. I would be more than happy if they configured CMS. So the point is simply this. Do you want to think and at least try to to understand engineering way of solving problems, or do you want to continue playing with toys? And finally, when you go out, start working, look back and blame that these skills were not taught. Let me ask you a very simple question. You have learned 3 to 4 programming languages till now. 3 to 4 programming languages, 2 to 3 different databases, 2 or more operating systems. At least you are exposed to all this. Now, when you have to finally make a choice, can you make a very informed choice? Can you make a judgment on which is better? Prescribe a solution to someone? If not, you should try in this course. This course is basically meant to give a hands-on experience to students so that they try building a real-time application and understand that textbook way of developing applications has its own limitations and how to overcome it. Please equate this course to internships of medical students, where they go and work with real patients and they try to apply their knowledge and try to see how they should prescribe solutions. Think of this course from that perspective. Probably then you will understand what you have done. Basically, the choices before you are very clear on how to go about in this course. In fact, it has been said in all of your courses, I assume, and at least I will say it in most of my courses, that engineering is nothing but what? Picking a solution from possible solutions. If there are many solutions to the problem, picking up the right solution which satisfies the requirement and works within the constraint is engineering. So there are 2 takeaways from this. One is there should be more than one solution. Second, you should know how to pick the optimal solution. Write it in bold letters. Probably you can serve as a good t-shirt slogan. One solution is no solution. This is a classic saying in engineering. One solution is no solution. If you are telling me that there is a problem I am going to solve in this way, no. Aren't there other ways of solving this? Why are you not choosing that? Why are you sticking to this? This is the question which you need to answer. In fact, the same theme is answered in almost all your courses, but the problem disguises itself in different forms. Last semester we did an experiment. We said that when the student is encountered with the problem of how to manage data, he basically has 2 choices. Either using databases or using files. So we said let him develop the same application using both the formats. Ultimately let him understand which is better. The experiment was tried. Let us not discuss about the results. But anyway, anything which is done for the first time will have resistance or resistance. This is normal. We who introduce new things have to go through all this, but in most of the scenarios this question will come before you. When there are different choices, how to do that? selection. I hope in some course or other this may have been dealt. I am not very sure. But if it is not dealt, I will engage in a brief discussion on how to select the concept among competing ideas. The basic framework is this. Let me reiterate, it has been told to you, but let me again reiterate. We have asked you to do very simple things. We want you not to build the solutions. Let me repeat this, not building a solution. Because every day I get students who come and ask me, I am doing this, can I use this CMS? This is a wrong question. Who is bothered about what you are using and how you are using? Not the concern of this lab. The concern of this course is precisely this. Do you know what to do? Do you know how to do? That's all. Actually building an application is not engineering concern at all. I am surrounded by electrical sciences labs, high voltage lab and measurement lab and all. I envy the way they work. Without the proper work on paper, they will not be allowed to go to machines and do their experiment. Take any engineering way of doing things, circuit design, constructing a building a dam. Will someone say, I say build a dam, okay, bring 1000 bricks, bring 10 kg of cement, concrete, mix muddy, start building bridge. Come on, does it happen? So no. If you want to build a new car, will you say I need this many kgs of whatever steel or whatever material is required? Bring that, let me start grinding parts together. Does it happen? No. Anything and everything in engineering should start with a solid design on paper. You prove the design on paper, then start the actual implementation. What is engineering? But we don't seem to understand that. For us, when we say build an application, go to the computer, start building. I think the basic problem is because we understand very well that it is very inexpensive to build and then destruct. You can't build the buildings the way we are writing the software. Nobody builds. Classic example, testing. I was telling someone on how we have neglected testing altogether. Nobody knows how to test. How do we test? We write an application, run the application, give some test data. If it works, fine. If it doesn't work, not fine. This is not testing. This is like build a building. Drop 10 kg stone. If it breaks, again build it. If it doesn't break, put a 50 kg stone. Doesn't build 100 kg stone. That's testing happening anyway like this. And how do we find errors? Compile. Compiler, which is a tool to do something else, is used by everyone to find errors. We have made such a mess of this thing. I don't know when and from where we should start preparing this. The same problem is also there in the lack of importance given to design. I have told this to other section people, I am telling you now. There is no hurry from my side. There is no force from my side that you should go in install CMS and start working in the lab. I am least bothered. Get me the concrete design on paper, I am happy. Implementation does not take more than half an hour. So from now onwards, I prohibit from you working on the system in the lab if you don't submit a thorough, complete, consistent design document. That we use all the time available in this semester to fine tune our knowledge on how to write a design document. I will be more welcome. Implementation you can do on your own, I am very sure. I have no doubts regarding it. Because the implementation issue anyway are so complex that I think you are yet not ready. For example, I was telling someone the other day when they told me that their project was all about, take any project,